Okay, here we're going to talk about some new terminology. So, a complementary angle, you might remember from a while ago, and that is the sum of two angles, is 90 degrees. Sorry. So, we're going to see if we can find any patterns using this idea of complementary angles. So if we have this triangle here, we know this is angle B, this is angle C, this is angle A. And we know because this is 90 degrees and this is a triangle, angle A and angle B, have to add up to 90, right? Because that's the only way we'll get to 180. So we're going to fill in these values here just with the definition, so ratios. So if I'm standing at B, I want to know sine of B. That will be opposite over hypotenuse. Okay. So I'm going to go down the list. So I'm still standing at B. Cosecant is its reciprocal for sine. So that means, and we're still at B, that means this has to be C over B. And now tangent of B, well, that's going to be opposite, so B over adjacent A. All right. So right now we're just writing the definition. So cosine of A, well, that's going to be, I'm standing at A now, so here I am. That's going to be adjacent, so B over hypotenuse. Secant of A is the reciprocal, and because we're still standing at A, so that would be C over B. And cotangent of A, well, remember, that's going to have to be, excuse me, it's going to be adjacent over opposite since it's cotangent, so that's going to be B over A. All right, let's keep filling this guy out. Cosine of B, all right, well, that's going to be adjacent, so let's go get rid of him because we're no longer at A. Cosine of B, so now we're standing back here. Cosine is adjacent over hypotenuse. Secant of B, well, that's going to be its reciprocal. Cotangent of B, well, that's going to be adjacent over opposite. All right, so for the last column, I'm going to hang out at A. Sine of A is A over C. Cosecant of A is this reciprocal, so that would be C over A. And tangent of A is opposite over adjacent. So, what do we see? These guys, and these guys. Don't they all produce the same thing? Well, as pairs. So this guy equals this one, right? This one equals this one because they're producing the same ratio. And this is equaling this one. And that is the same for over here. These are producing the same thing. These are producing the same thing. And these are producing the same thing. So what in the heck does that mean? Well, we see a pattern. So we're going to go ahead and we're going to give this a name. So the ones that are paired up, they're known as cofunctions. So sine and cosine are cofunctions. And I'm going to make more sense of this in a second. Cosecant and secant are cofunctions. And cotangent and tangent are cofunctions. So what I'm seeing here, and the fact that the two angles we're dealing with are complementary, what this is telling me is cofunctions of complementary angles are actually equal. But they have to be complementary. All right, so they have a pair. So sine goes with cosine, secant goes with cosecant, and cotangent goes with tangent. So what I want us to look at here is 12 degrees and 78 degrees. Are they complementary? Are they 90 degrees? Well, 78 degrees plus 12 degrees does equal 90. Okay, so maybe we can use this information. The other thing I want to ask is, are they cofunctions? Well, are tangent and cotangent cofunctions? So tangent and cotangent. Well, they are. So what this means is, since these are both yes, that means they are equal. So what I can do, because they're equal, it does not matter which one you're going to replace. I know that I'm saying something minus what it's equal to, this has to equal 0. Has to. Another way for me to explain this is, well, since these guys are equal, you can just replace one with the other. So I can say, okay, well, this is tangent of 12 degrees minus, I'm going to replace this with what it's equal to, which is tangent of 12 degrees. So that's how I get 0. You don't have to show work on this, but that's me trying to better explain it. So for B, are cosine and sine, or let me start the other way. Are 40 degrees and 50 degrees complementary? Yes. Are cosine and sine known as cofunctions? Yes. So this is saying I have something divided by itself because these are equal, so that's why I get 1. Another way for me to explain this is you can replace just one of them with what it would be equal to. We're going to practice this more in class, but I just wanted you to know they have to be complementary, and if they're cofunctions and they're complementary, then they're equal to each other. All right. That will take care of these notes, and then last video we'll be talking about when your radius is not 1.